How to analyze, design and detail isolated footing in SAFE software. Here I will start the new model file, new model. Here is the design code. Whatever is your country, you can select the design code. It's Italian, Canadian, Eurocode, IS, Indian Standard or American Concrete Institute. Here I am selecting the latest code. Here is the design preferences. You can select preferences like what is a design factor for tension control or compression control for shear. It is based on code, so I recommend please do not change these codes, these factors. Here is a minimum cover, so here is a 0.75 inch, so that will be 20 millimeter minimum cover for beams, that is for post tension. So here I'm clicking OK. And second, project information, you can put here client name, for example David, project number, project name, for example training, and similarly you can put for example project number. All these things you can put here in the information. So what is the benefit? Basically when you go for the creating a report, so software automatically pick this information. Okay. And the last one is the unit system. So which unit system you want to work? Here is both unit system, US default and means FPS system, and second is metric system, means kilonewton meter system. And here is the consistent, you can select any unit system, kg whatsoever, kg millimeter, kg millimeter, kg centimeter. So that's how you can pick the unit system. So here in this example I will pick the metric defaults kilonewton meter system. I will click OK. And here is the initial templates. You can either start the work from these templates like single footing. Software automatically take the slab thickness. Here you can change and all the things software automatically pick. Here the combined footing, so I am start from the base level. So here I will draw all the things. I am clicking blank. Okay, after clicking blank I will go in the define properties material. Here I will define new material, for example for concrete 24 megapascal. Okay, and here material type you select concrete, and this property window will appear. Here is a unit volume, unit weight of the concrete, that will be remain constant. Modulus of elasticity, Poisson's ratio, coefficient of thermal expansion, shear modulus. Here is a specified concrete compressive strength, that is at 20 megapascal. 1 Newton per millimeter square is equal to 1 megapascal. Here I will put 24 megapascal, and here I will put the formula. Then software automatically calculate the modulus of elasticity, equal 4700 multiplied by 24 power 0.5. That is the formula 4700 square root of 24. That is a SI formula. For FPS system you have to do 57,000 under root FC prime. Here I will hit OK. Software automatically calculate the modulus of elasticity. So Poisson's ratio, that will be constant, remain same. Coefficient thermal expansion, that will also remain constant. Shear modulus, software automatically calculate. I will hit OK. And here is a predefined steel, so I will also define the steel means reinforcement, that will be for 20 megapascal. Here I will select rebar. Here is the unit volume, that will not change. Here is the modulus of elasticity. You can enter 200,000, 200 GPa, gigapascal. Here is the minimum yield strength. Here I will put 420 megapascal, and ultimate strength 620 megapascal for 420 megapascal grade 60 steel. Okay. Now I will define the slab property. Here I will define two properties for slab and for center column. Here I will define the footing with 300 millimeter thickness. and here I will click the slab material property. That will be concrete 24 megapascal. That will be thick plate, means all the plate will be act as a to take the bending moment, shear, all the things. This will behave like a slab. Here is a orthotropic, means if the slab have different thicknesses in different directions. For example, in x direction, what is the thickness of the slab, another direction, what is the thickness of slab. So in our case, the same thickness is for the whole footing. So I am not changing, going to orthotropic. So here I will hit OK. Now I will define another property for column. Add copy of this. Here I will define stiff column. Okay, the column property will also be concrete 24 megapascal. Here I will select stiff. Its thickness will be also 300 millimeter. Okay. Okay, now I will define the soil subgrade modulus. Soil subgrade modulus is basically the behavior of footing, and for example in real situations, under the footing there is soil, and soil may have major two properties. One is the bearing pressure, allowable bearing pressure, and second is the allowable settlement. For isolated footing, there is a allowable settlement that will be 1 inch, means 25 millimeter, and for the allowable bearing capacity that will become from the geotechnical report. Modify. Here I will click soil, and uh, its bearing capacity and 100/25. That is just for my remembering purpose. You can put any name. And here is the soil subgrade modulus. Here I will put equal 100 divided by 25 divided by 1000. Here basically what I did, I divided the, for example, my allowable bearing capacity is 100, 200. For example, in this example, I'll take the bearing capacity 200, allowable bearing capacity, that is a 200 kPa, and the allowable settlement is 25. I am dividing the bearing pressure with the settlement. Here you can see. Here I will hit OK. Software automatically calculated to 8000 kilonewton per meter cube. And here is a for condition: none linear tension. For tension, our for example, if the column is pulling, in pulling situation, then we select the tension only. But in our case, the load from slabs, beams, and slabs, beams come onto the footing, and the footing is in the compression sense, so that's why we select the compression only. So here is about soil subgrade modulus. Soil subgrade modulus is the pressure divided by deformation. It is a basically spring constant. So here pressure is the allowable bearing pressure, deformation is the allowable settlement. For example, our bearing pressure is 200 kPa and the allowable settlement is 25 millimeter. So the soil subgrade modulus will be 200 divided by 25. 25 divided by 1000 is because I am converting into meter. 25 millimeter into meter. So that's why the answer is 8000 kPa. Here is our we will check the bearing pressure. If the pressure under the footing is less than 200 kPa allowable, it's okay. Deformation means settlement is less than 25 millimeter, that is also okay. If the shear, I mean applied shear divided by shear capacity, if it is less than 1, so that is also okay. Preferably that should be less than 0.9, but if it is less than 1, so that is okay. If anything is going to failure, then we will change the dimensions, thickness, or all the things. That's how I have defined the soil subgrade modulus with 200 kPa divided by 25 millimeter allowable deformation. Here I have put it 8000. You can see here I have calculated 8000 kilonewton per meter cube. Okay. Okay. Now I will go in these. There are different options for the draw mode. Before drawing, I will draw the grid. Draw. Edit grid data, add and modify grid. Here is the global grid system. Okay. I will modify. I will click spacing. Here I will add 1, 2. The thickness between the A and 1 and 2 is 3. So here I will draw another grid A, B. The distance between them may be 5 meter. Okay. Now I will hit OK. Okay. For isolated footing, this much grid is okay. I will draw the footing here or here, whatsoever, wherever I want. So here I will click draw. There are different options. uh, Draw slab. For draw slab I will click here. I will click first point, second point, third point, fourth point, and fifth point. This is one way of drawing slab or footing. So that is the option draw rectangular slab. For drawing rectangular slab I will draw. That's how I will draw the rectangular slab. Here is a quick draw slab. For quick drawing of slab I will just click between the grid system. Software automatically draw the slab. Control Z. But for isolated footing I will prefer quick draw around the points. Okay. I will select the footing type, matlab slab type. That will be footing 300 millimeter, and dimension of the footing will be 2.5 meter, 2.5 meter each side, x dimension and y dimension. I will just click at the grid location. Software automatically make the footing. Here I have just click the around the point, so that's why around the point. Escape. Now I will again click the quick draw around the point, and now I will select stiff column. Our column size is 300 millimeter by 300 millimeter. So for which column you are making the isolated footing, draw that column. So here I will put 300 millimeter. Software automatically convert into 0.3 meter. 300 millimeter. Software automatically converted into 0.3 meter. I will just click at the center. Here is a simulation or actual condition, that is a footing, that is a column. So now I will just select this lab and go to assign sport data soil properties. Here the property I have defined I will apply. Okay. So under that you can see the soil conditions have been defined in 3D. You can see here that is a sport condition.